In this video, we'll continue to look at how to integrate indefinite integrals using u-substitution. If you've not already done so, press pause to copy down these steps for u-substitution. Notice that we have one extra one added. This step we use if for some reason we have an x involved in our indefinite integral and we need to substitute for x. So this step is added to the ones that we had on our list previously. Our first example is to evaluate the indefinite integral 2x times the square root of x minus 3 times dx. Our first step is to choose a value for u in terms of x. We'll use x minus 3. Then we take the derivative of that equation, so we get du is equal to dx. And then that new step, solve for x in terms of u to make further substitutions. So now we have this equation, we solve for x and we get x equals u plus 3. Now we have an expression in u that we can use right here in place of this x factor. Make substitutions so that the expression that we're integrating is all in terms of u. So the original problem was integral 2x times the square root of x minus 3 dx. We're going to sub in u plus 3 in place of x. And then we have the square root of, and then u is going to be subbed in place of x minus 3. And then dx, we're going to sub in du in its place. Simplifying, the 2 can be brought out in front of the integral, and the square root can be written as exponent of 1/2. If we distribute the u to the 1/2 through the binomial, we have u to the 3/2 plus 3u to the 1/2. Now we're ready to integrate. So our 2 stays out in front. Increase the exponent by 1, so that's u to the 5/2 divided by 5/2, which is the same as multiplying by 2/5. And then 3 times, and then the integral of u to the 1/2. If we increase this power by 1, we get 3/2. So 2/3 times u to the 3/2. All we need to do now is substitute back, and in place of u, we're going to put back in x minus 3 instead of u. So, and I'm also distributing this 2. So 2 times 2/5 gives me 4/5 times the quantity x minus 3 to the 5/2. This product, the 3's cancel, and then when I distribute my 2 times this 2, I get 4 times the quantity x minus 3 to the 3/2 plus a constant. My next example, evaluate the integral of x plus 1 times the square root of 2 minus x dx. Our first step is to choose an expression for u. So I'm going to choose u to be equal to 2 minus x. So I write that down. Then take the derivative of that, and we get du is equal to a negative 1 dx. Then also we're going to need to solve for x here on this so that we have something to sub back into here. So we have x is equal to 2 minus u, and then make our substitutions. This is our original problem. So we put 2 minus u in place of x, and then we still have that plus 1. And then the square root of u. And then in place of dx, I need to substitute negative 1 du. The negative 1 factor I can pull out in front of the integral. Combining terms here, I get 3 minus u. And then the square root of u I can write as u to the 1/2 power. Now I need to distribute that u to the 1/2 power. So I have 3 times u to the 1/2 minus, and then remember you add exponents, so u to the 1st power times u to the 1/2 power gives me u to the 3/2 power. Now I'm ready to integrate. So I have my negative 1 from out in front. Increase the exponent by 1, which will give me 3/2. So I have 3 times 2/3, because dividing by 3/2 is the same as multiplying by 2/3, u to the 3/2. And then this should be a minus here. And then we integrate this one. 3/2 plus 1 is 5/2, so I have 2/5 u to the 5/2. Now when I distribute this negative 1 through, I have the 3's cancel, and I have negative 1 times 2 is negative 2. And then I sub back in place of u, I sub back 2 minus x. That's to the 3/2 power. Then this minus, when I distribute to this minus, I get a plus. And then 2/5, and sub back in place of u, 2 minus x, raised to the 5/2 power, plus c. Now I can rewrite this and put my positive term in front. So I can rewrite that as 2/5 times that quantity, 2 minus x to the 5/2, subtract 2 times the quantity, 2 minus x to the 3/2, plus c.